Hi everyone, welcome to the section on random forest classifier. So random forest classifier is an ensemble classifier because it consists of more than one classifier. So in random forest, we combine different classifiers in order to improve the overall performance. We can combine any kind of classifier in order to create the random forest. However, in this section, we will use decision trees in order to create the random forest classifier. Let's see what we are going to cover in this section. So these are the topics which we are going to cover in this section. First, we will study why we need a random forest. Although we have a decision trees, then why we need a random forest. Then we will study how random forest works. We know that it is an ensemble network. We will see how we can combine different decision trees network in order to create the random forest. So here we will study the working of the random forest. Then random forest has 4 important hyperparameters on which the performance of random forest depends. So we will discuss in detail about those hyperparameters of random forest. Then bootstrapping and out-of-bag error. So bootstrapping is a method of sampling from the original data. That is, in bootstrapping, we create subset of the features from the original features. So we will see how bootstrapping will be performed and what is the out-of-bag error, what will be the out-of-bag score, and why these are important terms. After that, we will implement the concept of random forest in Python with the help of 2 projects. So I hope you will understand this section very well. Thanks for listening, and I will see you in the section. Everyone, welcome to this lecture. So in this lecture, we will discuss the basic definition of a random forest, and we will also discuss why we need a random forest if we already have a decision tree classifier. So what is the definition of a forest? So the simplest definition of a forest is the area covered with trees. We can say that this is the definition according to geology or the environmental engineering. That is, the area covered with trees is called forest. So these are trees, and if we combine all these trees, or if we cover the whole area with the trees, that becomes the forest. So this is the diagram, or this is the image or a picture of a forest with respect to the definition. So why we need forest, or why we need random forest in machine learning? So these are the reasons why we need random forest, although we have a decision tree classifier. So we make a decision tree based on the information criteria. We know that from the previous section that we have entropy, we have a Gini information or Gini index. We use both of these or any of the method in order to find the information gain of all the feature of our data set. And based on the information gain, we start constructing tree. However, the problem is that we do not use all the features while making trees. That is, if a data set is large and it has many features, then there is a chance during the construction of a decision tree that we miss one or more than one feature. Okay, the other problem is the root node is always the same. We have already seen this, whether we use entropy or Gini impurity, the root node is always the same. The other is the feature selected for root node has enormous impact on the tree. By setting any criteria, we are unable to include all the sample of features while making the decision tree. So the major problem is that whatever criteria we select, the root node is always the same, whether we use entropy or Gini impurity, and root node is the most important part or most important element of a decision tree. It has enormous impact on the performance of a decision tree. And the other thing is that if there are large number of feature in a data set, there is a chance that during the construction of a decision tree, we miss one or more features. So here is the example. This is the same data set which we discussed in our previous section on the decision tree classifier. And this is the final decision tree of this data set. If we see that there is an important feature in the data set known as liver condition. And when the tree start and when the tree completed, there is no liver condition in that decision tree. So we can see that we have missed a very important feature known as a liver condition, and it is not anywhere in the split of the tree. So this is one of the most important reason. The other reason is that a decision tree with a large data set or with large number of features can overfit. It can grow up to maximum depth and can enter easily into the overfit condition. We have already seen in the previous section that the decision tree can enter into an overfit region, and in order to avoid, we have to prune the decision tree. So overfitting is also a problem with the decision tree. So in order to solve all these problems, we need a random forest. That is, the solution to all above mentioned problem is to make more than one tree, make a forest, and try to incorporate all the features. So I hope you understood this lecture. You understood why we need a random forest classifier, although we have a decision tree classifier. Thanks for listening, and I will see you in the next lecture. Hi everyone, welcome to this lecture. So in this lecture, we learn intuitively how random forests work. So basically in random forest, we do not use all the features of a data set at once, but we randomly select the subsets of feature. Based on those subsets of feature, we construct tree, and later on we combine trees in order to construct a random forest classifier. So here is the example. This is our data set, and our data set has those 5 features A, B, C, D, and E. So what is the first subset of the features? So this is the first subset of the features. We have randomly selected A, B, C as first 3 features of our subset. So the next step is that based on the subset of features, we design a decision tree classifier. Then we select another set of a subset, that is another subset of a features, that is B, C, and D. This time we selected B, C, and D, and then we design another decision tree classifier based on these subset of features. The next step is to pick another subset of features. This time we have picked C, D, and E as our subset of features, and we design another decision tree classifier. So here is the summary. So basically, we have 5 features in our whole data set. First, we select a subset of features as A, B, and C. These are the features selected in a subset of features, and we construct our decision tree. In the second step, we pick up B, C, and D as a subset of features, and we design or we construct our decision tree classifier. And finally, as a third step, we pick the features C, D, and E as a subset of features, and we design a decision tree classifier based on these subset of features. So these are the only 3 examples or only 3 subset which we have randomly selected from the whole data set. We could have selected more than 3 subset of features as well. So the final step is now we have to perform the classification using a random forest. So this is our decision tree 1, this is decision tree 2, and this is our decision tree 3. So these 3 will combine to form a forest. So what is the final decision of the forest? So the final decision of the forest is made on majority voting. So according to decision tree 1, there is a label y is equals to 1 to a particular class. The decision tree 2 is saying that the label should be 0, and decision tree 3 is saying that the decision should be 1. So based on the majority voting, the final decision is that the label of the particular class is 1 based on the majority voting. So in this way, we perform the random forest classification, and the final decision is made on the majority voting. Other than classification, if we perform random forest regression, in that case, the final decision is based on the average of the decision. So this is the decision of a decision tree 1, y is equals to 2. The decision of the second decision tree is y is equals to 5. And the decision of a third decision tree is y is equals to 4. Since this is a regression problem, so we will not go for the majority voting. Majority voting is only used for the classification problem. So what is the final decision? The final decision is based on the average of all the decisions of the decision tree in a random forest. So in this lecture, we intuitively learn and see how random forests work. We see the random forest is the combination of a trees of different subset of the features. So by creating random forest, we see that we have incorporated all the features in our random forest classifier, and there is no missing feature, which was a chance in a decision tree classifier. So I hope you understood this lecture very well. Thanks for listening, and I will see you in the next lecture. Hi everyone, welcome to this lecture. So in this lecture, we will discuss the hyperparameters of random forest. So hyperparameters are those parameters on which the performance of random forest classified depends. So we need to select them very carefully, or we have to use some algorithm or some method in order to decide about these hyperparameters. First hyperparameter is the number of estimators or trees. So basically, in this parameter, we adjust or we select how many trees we need in a random forest. Because if we increase the number of trees, it might not increase the performance of a random forest. So we will see how we can adjust the number of estimators or tree in a random forest. The second hyperparameter is the number of features to be included in the subset. So if we have a data set with 10 features, and we know that in order to construct a random forest classifier or design a random forest classifier, we select a subset of features. So how many features to be included in the subset? This is also a very important question. Therefore, the number of features is also a hyperparameter for the random forest. The next feature is a bootstrap sampling. So this is a new thing which we will discuss. And the last hyperparameter is out of bag error. So we are going to start with the number of estimators. So how many estimators, that is number of decision trees, require for random forest? So answer is that intuitively it seems that more the number of estimator, more is the chance of contribution of every sample of a features. But what about overfitting? So the question is, or the answer is that we can add more and more decision tree to our random forest so that we can get the improved performance and we can incorporate all the features of a data set. But on the other hand, what about the overfitting? This is the big question. So what about the overfitting of a random forest? So research shows that random forests do not overfit, or it is very less likely that random forest overfit. So it means that we can add more and more decision tree because random forests do not overfit. We can include as many estimator as we can in random forest. Increasing the estimator will not increase the complexity of the algorithm. So research shows that you can increase as many estimator in the random forest classifier because random forest classifier will not overfit. Now, these are the options of selecting the number of estimator. Research suggests that number of estimators should be between 60 to 150. So this is the value obtained by the researchers. The other thing is that we can find the number of estimators using grid search method. So we have seen in the previous sections of the course that we use grid search method where we provide all the possible combinations of a parameter to the model and model select the best parameter. So we can also use grid search method in order to find the number of estimator for a random forest classifier. The third method is find number of estimator using a plot between error and the number of estimator. That is, in that case, we get a error plot, and based on the error plot, we can select the number of estimator. So here is the example of a error plot versus number of estimator. We can see that on x-axis, we have number of estimator. So here we have provided 50 estimator and we calculate the error rate for each estimator. So when number of estimator or tree is 1, we can see that our error rate is very high. After that, it falls down, then rise and then fall. We can see the fluctuation in the value of error rate if we increase the number of trees or the number of estimator in a random forest. So if we see here, this is the minimum value of our error rate which we have reached for the very first time. This is also the minimum value, but this is the minimum value which we reach for the very first time. If we can see here, the value of number of tree is around 17. So based on this error plot, we will select the number of estimator is equals to 17. So this is also a very good and optimal method in order to find the number of estimators, that is calculate the error rate for each number of estimator and select the number of estimator which has the lowest value of the error rate. So these are the observations which we have learned about the number of estimators or a number of trees. Increasing number of estimator will not increase the information. It is observed that by increasing number of estimators, we are duplicating the results. So the situation is that if there are 3 trees which are enough for a random forest, and we keep on increasing the number of trees, so what will happen? The performance of a random forest will not increase, only we are duplicating the result, because finally we have to decide based on the majority voting. So even if we change the subset of features, we cannot avoid reputation of the trees. So basically, if we keep on increasing the number of estimators, we are not getting a new information about the dataset. We are only duplicating the results. So the best thing is, in order to find the number of estimator, either we should use grid search method or error rate plot method. So this is our second hyperparameter, that is number of features to be included in the subset. So how many features to be included in a subset? So different researches suggest that we can include log 2 of n plus 1 or square root of n in the subset of n number of features. So if I have n features, in that case, I can take the log of those values, that is log 2 n plus 1 or square root of n. For random forest regression, it is suggested that selecting n by 3 features is a subset is a better than square root of n. So this is about the classification, that is if we use a random forest as a classifier, and this is the suggestion if we use a random forest as a regressor. In that case, we have to select n by 3 features, and in the case of classification, we can either go for square root of n or log 2 of n plus 1. So here is the example that how we can calculate. So if we have n is equals to 90, in that case, the log 2 of 90 plus 1 is 6.5. So we cannot select the number of features is equals to 6.5. We will select either 6 or 7. Similarly, if we take a square root, we have the value approximately equals to 9.5. So also in this case, we will not select 9.5 because number of feature is an integer value. So we will either select 9 or 10. And this is n by 3, which will be used for random forest regression. So conclusion about the number of feature is that all methods for selecting number of features in a subset are experimental based method. So the good starting point would be to start with square root of n and then change the number of features if random forest is not performing well for square root of n. So the final conclusion about selecting the number of feature is go for the square root of n. If it does not work well, then we can change the criteria. So in this lecture, we learn about the first 2 important hyperparameters of a random forest classifier. That is, we learn how to select the number of estimators and how to select the number of features. In the next lecture, we will discuss about the bootstrap sampling and out-of-bag error. So I hope you understood this lecture. Thanks for listening, and I will see you in the next lecture. Hi everyone, welcome to this lecture. So in this lecture, we are going to discuss another 2 important hyperparameter of a random forest classifier, that is bootstrap sampling and out-of-bag error. So what is the definition of bootstrap sampling? So bootstrapping means sampling with replacement. That is, sampling with replacement is a random sampling that allows the sampling units to occur more than once. So basically in this sampling, we can select a data sample more than once. That is, in bootstrap sampling, we perform sampling with replacement. So what does it mean? So this is the example of a bootstrap sampling. This is our original dataset, and these are the 3 examples of bootstrap sampling. We can see that here we have selected data samples more than one. If we see in the original dataset, we have 2 red samples, but in the first example of a bootstrap, we have 3 red samples. Similarly, here we have more blue samples, and here we have more light blue sample. So these are the 3 perfect example of a bootstrap sampling, that is sampling with the replacement from the original data. So basically with bootstrap sampling, we create the subset of the features from the original data. So here is another example of a bootstrap sampling. We can see that along the rows, we have 5 samples. So we have selected A2, A1, A5, A4, A2, and A5. We can see that we have selected A2 and A5 more than once. So this is another example of bootstrap sampling. So why we need bootstrap sampling? So basically, we have seen that previously that the subset of feature is selected using this equation, that is log2 of n plus 1 or square root of n. So with bootstrapping, we extract more samples along the rows of a data, that is to bootstrap along the rows. With bootstrapping, we get different subset of features along the columns and rows, and thus we avoid correlation between the trees and repetition. So bootstrap sampling is a method of finding or extracting the subset of features from the original dataset. With bootstrap sampling, we have more subsets or more different subset of features. Thus, by bootstrap sampling, we can avoid the repetition of the results, the duplication of the results, or the correlation between the trees. So basically, with bootstrap sampling, we can sample along the rows of the data as well. So this is the example of a bootstrap sampling. Here we can see that this is our data set. It has features A, B, C, D, E, and these are the label of a data set, and these are the rows or the samples of a data set. So this is the subset of a features which we obtain using bootstrapping. We can see that we have select row 1, row 5, row 4, then 3, 10, and then 4 again. So these are the bootstrap samples. Now, what is out of bag error? So basically what is happening when we bootstrapping, then we can sample with replacement. So what happens if we do sample with replacement? In that case, few of the rows of features repeated in the subset, thus left some rows of a data unused. That is, we have some leftover samples. That leftover samples are called out of bag samples. So what we do with out of bag samples? So basically we use those out of bag samples to test the random forest model while being training. That is, before the completion of a random forest model, we even test the model on the out of bag samples. So what is the advantage? So we calculate the out of bag score. So out of bag score is 1 minus out of bag error. So the out of bag error is the number of misclassification by the random forest model on the out of bag samples. So basically, what is out of bag error? So when we do bootstrapping, in that case, we do not find the samples or we do not extract the samples from all the rows of a data set. So there are leftover rows. So the samples present in that leftover rows are called out of bag samples. We use these out of bag samples to test the random forest classifier, and the out of bag error is the number of misclassification. So if we see the misclassification, we calculate the misclassification, that is the out of bag error, and based on the out of bag error, we calculate the out of bag score. So here is the example. So these are our bootstrap samples, and these are our leftover rows. So during the bootstrapping, we did not select row 2, we did not select 6th row, 7th row, 8th row, and 9th row. So these are the leftover rows, and the sample present in that leftover rows are called out of bag samples. So we use out of bag samples to test the random forest classifier. We get the prediction from the random forest classifier while being trained, and then we compare the prediction of a random forest classifier with the original label of a dataset, and with the difference, we can calculate the out of bag error. Then we subtract out of bag error from 1 to get the out of bag score. So this is the advantage of bootstrapping, that we have a leftover samples in a dataset that are called out of bag samples. So we use out of bag samples in order to find the out of bag error and out of bag score. So even the random forest classifier is not completed, it is being trained. Even during the training, we perform the bootstrapping to get the out of bag samples and then to calculate the out of bag error. So what is the advantage of calculating the out of bag error during the training of the random forest classifier? So this is the advantage. So the out of bag error is used to check whether a model is overfitting or underfitting. If the OB error is higher than the model test error, this may be the indication that model is overfitting and not generalizing well to unseen data. If the OB error is lower than the model test error, this may be the indication that the model is underfitting and not learning all the patterns present in the dataset. So this is the advantage of OB error. Since the OB error is calculated during the training of a random forest classifier, we then later on compare the OB error with the test error of the model. And if there is a difference, this is the indication that whether a model is overfitting or underfitting. So with the help of OB error, during the training, we are able to find about the performance of a random forest classifier, that is whether it is going to underfit or overfit, or it is a good model. So in this lecture, we learn about bootstrap sampling and out-of-bag error. We learn that bootstrap sampling is another very important method in order to extract the subset of the features along the rows of the data. While performing bootstrap sampling, there are leftover features in a dataset, and that features are called out-of-bag samples, and we use out-of-bag samples in order to calculate the out-of-bag error. So I hope you understood this lecture. Thanks for listening, and I will see you in the next lecture. Hi everyone, welcome to this lecture. So in this lecture, we are going to solve our project 1 on a random forest classifier. So here I am inside my course folder. I have 3 major sections of the course: introduction, supervised machine learning, and unsupervised machine learning. So click on supervised machine learning. So here inside supervised machine learning, I have a random forest folder. Click on this folder. By clicking on this folder, here I have my project 1. Click on this file so that we can open it in our Google Colab environment. So here I am at my project 1. So in this project, I am going to use a breast cancer dataset, which I will load or import from sklearn.dataset. Similarly, I need pandas, numpy, and matplotlib in this project. I also need train test split, which I will import from sklearn.model selection. I need confusion metrics, F1 score, precision score, recall score, accuracy score, and confusion metrics display, which I will import from sklearn.metrics. So let's run this cell to import all the Python libraries. Now it's time to get the dataset. So I will load the breast cancer dataset in the form of data frames. Let's run this cell. So we can see that we have successfully loaded our breast cancer dataset, and we can see that we have 569 rows and 31 columns in that dataset. So out of these 31 columns, we will use first 30 column as our feature, because if we scroll towards right, we can see that the last column are our targets or label, and they have 2 values, that is 0 and 1 here. Okay, so we have already downloaded the dataset. Now it's time to check the null values in the column of a dataset. So the command is df.isNull.sum. Let's see. So we have seen that there is no null value in any of the column. So the data is clean. Now it's time to extract features and target. So all the column except the last column of the dataset will be used as a feature, and only the last column will be used as a label. Let's run the cell to extract features and targets. And now we can observe our feature. We can observe that the size of our feature matrix is 569 by 30. Let's see how many unique labels are available. So there are 2 unique labels, that is 0 and 1. So since feature and label have been extracted, now it's time to perform train test split. So for train test split, I am passing input parameters X and Y. So the test size I am going to use is 0.2, that is 20% of the data will be used as a test, and remaining 80% of the data will be used as a training. So I will get 4 output here, that is the training component, the testing component of the data, the training labels, and the testing label. Let's run this cell to perform the train test split. So train test split has been performed. Now it's time to instantiate the random forest classifier. So here there is a typo. Okay, so instantiating random forest classifier and fit to the data. So the first step is that from sklearn.ensemble, we will import random forest classifier. Since we are going to learn very first time about the random forest classifier, so we know that when we will use any function for the first time or any module for the first time or any classifier for the first time, it's better to check the document of that classifier so that we can see what are the important input parameters that can be given to that classifier. So I will import random forest classifier from sklearn.ensemble, and here after importing I am passing random forest classifier in a help function so that I can see the document of the random forest classifier. So let's run this cell. So here we can see that the document has been open. Now we have to scroll all the way to the up so that we can see the important parameter in the random forest. So this is the important line. So in the theory, we have learned that there are 4 hyperparameters of random forest classifier. So here is our first. So the number of estimator they are using by default is 100. That is, they are using 100 trees in order to construct the random forest. So the basic criteria is Guinea, so that they are not providing any maximum depth. Let's see what are the other important parameters. So this is another important parameter. In order to select the features in a subset, they are using the square root of criteria. If you remember in the theory, we study that the maximum feature in a subset should be square root of n. So they are using the square root criteria. Let's see what other important features are available. So we can see that the bootstrap is true and OB score is false. So we do not need to enter about a bootstrap. By default, it is true. But if we want to see the OB score, we have to set this false value to a true value. So we have seen all the 4 hyperparameters. So the OB score is false, the bootstrap is true, and similarly, the features in a subset are using a square root criteria. And we can also see that the number of estimator by default, they are using 100. So in this way, we have observed all the 4 parameters and we have seen what are the default values they are using. Now, what we are going to do, we have changing few values. So the maximum feature, we are still taking the square root criteria, and number of estimator we are using is 10. Okay, let's run this cell. So we have instantiate random forest with number of trees 10 and maximum feature equals to square root. And then after instantiating, we have fit our random forest classifier to the training data. Now it's time to get the predictions from the test data. So here our random forest is rf.predict. It will give us the prediction of a model on a test data. So after prediction, it's time to calculate the accuracy. For accuracy, we will compare the original testing label with the predicted label of the model. So we can see that we have quite a high accuracy of 95.61. Let's generate the confusion matrix of this classifier. So we can see that we have 5 misclassification values only, and all these values 40 and 69 are classified correctly. Now it's time to find the precision, recall, and F1 score. So we are using precision score function, recall score function, and F1 score function, and we are passing y-test and y-pred. And after calculating all these scores, we are transforming these values into pd.data frame, and we calling this as a matrix. So let's run this cell, and here we can observe the matrix. So our accuracy is 95.6, our precision is 95.5, our recall is 95.1%, and it is F1 score, which is also 95.3%. So we have quite a high values of these metrics. So we achieved 95.61, where we used most of the default values. Now it's time to apply grid search method. For grid search method, we know that we have to pass all the possible combinations of the parameter to the model, and then we get the best parameters from the model. So the first step is that we have to import grid search cross validation from sklearn.model selection. And similarly, I have to use kfold from sklearn.model selection. Let's run this cell to import these functions. Now, these are the 4 hyperparameters. So I have to give the possible values of these hyperparameters to the model so that model can select the best value. So the number of estimator I am providing are 10, 15, 20, 25, 30, 40, 50, 70, 100, 150, 200, and 250. And we know that 100 is the default value. Let's see what model is going to select. Similarly, the maximum feature in a subset, we are giving the input parameter 2, 3, 4, 5, and 6. Bootstrapping we need, therefore we are passing it as a true. And this time we also need OB score, therefore we are passing it as a true. So these are our parameter. Let's run this cell. And here we are creating a grid, parameter grid of those parameters. And in this cell, I am going to pass these parameters to my model. So K is equals to 5. That is my split is equals to 5 in cross validation. Here is my model, random forest grid search cross validated model RFGSCV, which I will get by instantiating my random forest classifier. Here I am using a grid search cross validation on my model. This is my model. I am passing parameter grid, that is all the possible combinations of the parameter. And here CV is equals to CV, which I have calculated from this step. Here I am going to fit my GS, that is grid search random forest classifier, to the training component. And here I am getting the parameters. So I will run this cell and it will take some time. Let's see. So we have run this cell. It is taking some time. So I stop this lecture here. I will see you in the next lecture when we will get the best parameters. Hi everyone, welcome to this lecture. So this is a lecture 2 on our project 1, where we were learning how to implement random forest classifier in Python. So in the last lecture, we were here where we have passed all the possible combinations of parameters to our model. So these are our 4 hyperparameters. These are all the possible combinations of these hyperparameters. Here we have created the grid of these parameters, and here we have passed all the parameters to our model so that we can get the best parameters from our model. So if I scroll down, our model has calculated the best parameter. We can see that these are our best parameters here. That is bootstrap is equals to true. Similarly, maximum feature is equals to 3, number of estimators 250, and OB score is also equals to true. If we see, we have a repeated warning message, and the message is some inputs do not have OB scores. So we do not need to worry about this message. The reason is, since we have provided different combinations of input, so there are few combination of inputs which do not have the OB score. So that is the warning. But here we can see that our OB score is true. Number of estimators, the model has already been provided us. So the model has provided us the best parameters. Let's use these parameters in our random forest classifier and see the accuracy of the model again. So now I am using number of estimator equals to 250, which I obtained from a grid search. Maximum features is equals to 3, which I have already obtained from the grid search method. And random state is 101. OB score is equals to true. So here I am instantiating my random forest classifier with new grid search values. And here I am fitting my classifier to the training component. So let's run this cell. So here we have fitted our classifier to the training component. And here I am going to get the predictions from a testing component of a data. Let's run this cell to get the predictions. And it's time to see the accuracy after grid search cross validation. So we can see that our accuracy has improved to 96.49. Previously, without grid search, it was 95.61. So we have improved the accuracy around 1% only. The question is whether it is a good improve or not. The answer is it is a good improve because we have already at 95.61, which is quite a high value of accuracy. So improving the accuracy after 95.61, it's not an easy thing. But using grid search cross validation, we have improved our accuracy. Okay, now it's time to calculate the out of bag score and error. So out of bag score will be rf.ob score. RF is our random forest classifier. Let's run this cell. So our OB score is 96.48. We can see that this is approximately equal to our average accuracy. Okay, now it's time to check the out of bag error. So it is the difference of 1 minus OB score. So this error is very small because we have a large value of OB score. Let's see the confusion matrix after grid search cross validation. And we can see that here we have only misclassification, one misclassification. Previously, without grid search, in our confusion matrix, we had two misclassification in this cell. Okay, now use another method. There is another method where we can find the number of estimators, that is number of trees which we require to use for our random forest classifier. And this is our error rate plot which we have learned in our theory lecture of this section. So in the error rate plot, we will calculate the error rate with different number of trees, and we will select those number of trees for our random forest for which the error rate will be very low or the minimum. Okay, so here I am using the word errors. So I am creating the empty list here. Here I am running my for loop and I am providing 50 different values of estimator. For these 50 different values of estimator, I will instantiate my random forest classifier. Here I am using a maximum features is equals to 6. I think we should use maximum features is equals to 3 here, because maximum feature is equals to 3 when we use grid search. So after grid search, model give us the parameter value equals to 3. Let's use this value here. So the maximum feature we can use is 3, which we have obtained after grid search. Okay, bootstrap is equals to true. So here I will here I will fit my random forest classifier to the training component of a data. Then I will get the predictions. I will compare the predictions with the testing label so that I will get the accuracy score. Then I will subtract the accuracy score from 1 so that I can get the error value. So every error value which I calculate using this for loop will be appended to this empty list. Okay, let's run this cell to calculate the error rate of 50 number of estimators. Okay, so error rate has been calculated. Now it's time to plot the error rate versus the number of estimators. So we can see that here we have number of estimator and these are our error rate value. Let's find the minimum value. So if we see, this is our minimum value where the error rate is minimum. So what is the value of number of estimators here? So it seems that this value is approximately 18 here. So we can calculate, since we have a markers here, we can easily calculate 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, and this value is 17 here. So this is 17. So now replace number of estimator is equals to 17. Okay, maximum features are 3. Let's check it again. So the maximum feature are 3. So we have to replace this 6 by 3 here. Okay. So the number of estimators obtained using error plot are 17. So maximum feature is 3. Okay, so now it's time to instantiate our random forest classifier again for these parameters and then to fit to the training components. Let's run this cell. Let's see our predictions. And here we are getting the accuracy. So our accuracy is 95.61. So with error rate plot, we are getting the same value of accuracy, which is 95.61. It means when we use number of estimators is equals to 10, that is the value without any method, without any grid search and without any error plot, that value was also good. But with grid search, we obtained the best value for this data set, that is 96 point something here, 96.49. And with error plot, we are duplicating our result. So in this lecture, we learn how to use random forest classifier with Python, how to implement random forest classifier with Python. We tested our random forest classifier in 3 different conditions. That is, without any method, we put the manual values of our feature where we take number of estimators is equals to 10. Then we apply grid search cross validation on our random forest classifier and we get the best parameters from the classifier. And finally, we use our error rate plot in order to find the best number of estimators. So we have seen that with all these 3 different methods, our random forest classifier has performed very well on the given dataset. So I hope you understood this project 1. Thanks for listening, and I will see you in the next lecture. Hi everyone, welcome to this lecture. So in this lecture, we are going to solve our project 2 on random forest classifier. So here I am inside the random forest folder, and this is my project 2. So click on this file so that we can open it on our Google Colab environment. So here I have successfully opened this project 2 in Google Colab environment. So for this project 2, I will import NumPy, Matplotlib, I will import train test split, and I will also import pandas. Okay, let's run this cell to import these files. So for this project too, I am going to use Titanic train dataset. We have already used this dataset for the previous classifiers. Okay, so this dataset is present in our random forest folder, and we know in order to read or import the dataset from the folder, we need to mount the drive and we need to set the path. So here we are going to mount our drive. Okay, so mount the drive. Here Google is asking for the permission. So we have to permit the Google so that we are able to mount the drive. So we can see that the drive is being mounted. So drive has been mounted here. So inside the drive, I have my drive. Inside my drive, I have a course material. Inside course material, I have supervised machine learning. And here is my random forest. So inside the random forest, I have Titanic train.csv dataset. Therefore, I have set the path, that is drive, my drive, course material, supervised machine learning, and then the random forest. Let's run this cell to set the path. And now it's time to import the data. So we can see that after mounting the drive and after setting a path, we have successfully imported our data here. So the size of data is 891 by 12. Let's see the head of the data. So we can see that we have 12 columns here from passenger ID to embarked. Okay, so there are columns which are irrelevant. There are columns which are categorical, and there will be some column where there are null values. So it's time to perform some data preprocessing steps with this data set. Okay, so the first step is we are going to drop irrelevant features. So the irrelevant features are passenger ID, name, ticket number, and the cabin. So these are irrelevant features because they do not have any effect on the labels. So the label of this dataset are 0 and 1. That is, this is the labeled column which is survived. 0 means the passenger died and 1 means the passenger survived. Okay, so these are the irrelevant features. So let's drop these irrelevant features. Okay, now it's time to check for the null values if there are any null values in any of the column. So we can see that there are two columns, age and embarked. So we have null values in those columns. So those columns are different from each other. In age column, we have a numerical value, and in the embarked column, we have the categorical value. We can see here in the age, we have the numerical value, and in the embarked, we have the categorical value. Let's deal first with the age column. So what we are going to do, we are going to replace all the null values in the age column with the mean value of the age. So here we are going to fill the null values with the function fillNull, and the value is that we are going to calculate the mean of the age column, and then we are replacing the null values with the mean value of the age, and we want to make it a permanent chain. Therefore, in place is equals to true. Let's run this cell. Now it's time to check the null values again. So we can see that the null values from the age column has been removed, and they are left only with the embarked column. So in order to solve the null values in the embarked column, what we are going to do, we are dropping all the rows of our data set where there are null values. Let's run this cell. And now it's time to check the null values. So we can see that there are no null values in any of the column. Let's see the head of the dataset again. So now we are left with the categorical features, which is sex and embark. We know that how to deal with the categorical features. So in order to deal with the categorical features, we have to create the dummy variables for these column, that is for the column sex and for the column embark. So here we are creating the dummy variable, and after creating the dummy variable, we are dropping the first column to avoid the multicollinearity. So let's run this cell. So the dummy variables have been created. Now it's time to add or concatenate those dummy variables to the original data. So the original data is called train. These are two columns of a dummy variable. Now concatenate these two dummy variable columns with our train. So we can see that these are the dummy variables male, Q and S. Q means Queenstown and S means Southampton. So we have successfully concatenated the dummy variable columns in our dataset. Since the dummy variables for sex and embarked has already been created, now it's time to remove those columns from our dataset. So here we are dropping sex and embarked column. That is this column sex and embarked. Okay, and we want to make it a permanent change. Let's run this cell. Now we have a clean data set. So we have removed all the null values. That is, we have dealt with all the null values. We have created the dummy variables for all the categorical features. And now the data set is clean. Now it's time to extract features and label. So all the columns except the survived column are our features. So here we are dropping only the survived column and we are keeping the rest of the column in order to get the feature matrix. So this is our label matrix. So label will be only the column survived of a dataset called train. Let's run this cell. Now it's time to perform a train test split. And for a train test split, we are going to use 20% of our data as a testing and 80% data as a training. Let's run this cell. And here we can see the shape of our testing data. So we have 178 sample in our testing data. Now it's time to apply random forest classifier. Okay, so the first step is that we are going to import random forest classifier from sklearn.ensemble. Here I am instantiating my random forest classifier with the number of estimator is equals to 10 and maximum features. We are using the square root criteria. Here I have passed the random state value. Now I am going to fit my random forest classifier to the training component of the data. Let's run this cell. Now it's time to get the prediction from the testing component. After getting the prediction, it's time to observe the accuracy. Let's run this cell to get the accuracy. So we can see that the accuracy with the random forest classifier on this Titanic dataset is 77.53. Okay, let's generate the confusion matrix. And let's see the confusion matrix here. So we can see that we have quite a large number of misclassifications, that is 25 misclassification here and 15 misclassification here. These are all the values which are correctly classified, that is 84 and 54. Now we can also find the precision, recall, and F1 score. So I am going to use a precision underscore score function, recall score, and F1 score. And for all these three functions, I am going to pass the same input parameter, that is y-test and y-pred. Let's run this cell and see those parameters in the form of pd.dataframe. So we can see that our accuracy is 77.5 and precision is high, 76.6. Recall is also high, 77.6, and F1 score is 76.8. So these are the value of a random forest classifier. These values reflect the performance of a random forest classifier when we use the manual values, that is number of estimators is equals to 10. Now it's time to get the values from the grid search cross validation. So here we are finding the parameters using a grid search cross validation. Okay, so for grid search cross validation, I am going to import grid search cross validation from sklearn.model selection. Similarly, I am going to import k-fold from sklearn.model selection. Let's run this cell to import these functions. Now here I am passing a different value for a grid search which I used in my project one. So look at the values at the number of estimator 2, 4, 8, 16, 32 up to 256. So the maximum features are 2, 3, 4, 5, 6. So the bootstrapping, we are passing the true value for the bootstrapping. And for OB score, we are also passing a true value. Here we are creating the parameter grids from all these defined parameters. Here I am using k is equals to 5. And then I am finding the 5-fold cross validation. Here I am instantiating my random forest classifier. And here I am passing my model and parameter grid so that I can get the best parameters from the training component. Okay, so I have to run all these three cells. Here I have created all the possible combinations. Here I have created the parameter grid. And if I run this cell, I will be able to find the best parameters. So let's run this cell. So it will take some time. So I stop this lecture here. I will see you in the next lecture. Hi everyone, welcome to this lecture. So this is our second lecture on project 2 on random forest classifier. So last time we were here where we have passed all the possible combination values of our hyperparameter to our random forest classifier. Now our random forest classifier has given us the best possible values of the parameter. So these values are bootstrap is equals to true, maximum features is equals to 4, number of estimators is equals to 16, and OB score is equals to true. We can see that we also have few warning messages. So we do not need to worry about these warning messages. We have discussed about these warning messages in the previous project as well. So they are saying that some inputs do not have OB score. Since we have passed the different possible combinations of the input to the model, therefore there are few inputs combination for which we cannot calculate the OB score. So this is the warning and we do not need to worry about because our model has calculated the best possible parameters for us. Now it's time to use these best parameters in our random forest classifier. So here I am instantiating my random forest classifier with number of estimator is equals to 16, which I obtained from grid search cross validation, and maximum features is equals to 4, which I also obtained from grid search cross validation. Okay, so instantiate our random forest classifier and then train it on the training component of our data set. Let's run this cell. Now, after training, it's time to get the predictions from the model. So here are the predictions. Now it's time to see the accuracy. So we can see that our accuracy is 78.65. If I scroll up, what was my accuracy without grid search? So my accuracy without grid search was 77.5. After grid search, I have obtained the average accuracy value of 78.65. So my accuracy has been improved by selecting the best parameter using grid search cross validation. Now it's time to see the confusion matrix here. Okay. After that, we also use the error rate plot in order to find the number of estimators for a random forest classifier. That is the number of trees. So for this, I am going to plot the error plot, and from that error plot, I will select the number of estimator and number of tree for my random forest classifier. So this is the same code which we used in our project 1. Here we are creating the empty list of errors. Here I am using a for loop and I am passing the 50 values for my estimator. Okay, here I am using the maximum features is equals to 3. Let's see what is the maximum feature which we obtained from grid search. So we obtained maximum features is equals to 4. It means we have to replace the maximum feature value from 3 to 4 here. Okay, now after instantiating my random forest classifier, I am fitting it to my training component. Then I am getting the predictions from the test component. After that, I am calculating the accuracy and subtracting it from 1 to get the error. And finally, I am appending the error to the empty list. Okay, let's run this cell. So we can see that we have the error. So error is that we got an unexpected key argument maximum features. So we have typed here maximum feature. So what is the maximum way, or it is max underscore features. So the standard way to input maximum feature is max underscore features. So now we have corrected our error. Let's run this cell. So after running this cell, we have calculated the 50 value of the errors. Let's plot these values. So here is my plot. So I have seen that this is the minimum value, and the minimum value from the error plot is obtained when number of estimators or tree is equals to 10 here. Okay, let's use this value. So the number of estimators I have to use is equals to 10. The maximum features are 4. Let's confirm. So the maximum features are 4. Okay, so the number of estimators obtained from the error plot is 10. This 10 is the value at which the error rate is minimum. Okay, let's run this cell to perform two tasks. That is to instantiate the random forest classifier and fit the random forest classifier to our training component. Let's run this cell. And now it's time to get the prediction. And after getting the predictions, it's time to see the accuracy. So we can see that now our accuracy is highest as compared to any previous method which we use in this project. Now our accuracy is 79.78 with the error rate plot. If I compare it with the grid search, in a grid search, we have 78.65. So using error plot, we have increased the accuracy about 1%. So in this project, we learn how to use random forest classifier in Python. We use the challenging dataset, which is the Titanic terrain dataset. We apply three methods on our random forest classifier, or basically we test the performance of our random forest classifier in three different conditions. Okay, the first condition was that we use the parameters value manually. We select the parameter value manually, and here our number of estimator is equals to 10, and we use maximum features criteria square root. So we get the accuracy of 77.53. Then in order to improve the accuracy, we use grid search cross validation method with our random forest classifier. And with that, we get the accuracy score of, here we get the accuracy score of 78.65, which is high as compared to the condition where we use the hyperparameters manually. Then we use another method. We plot the error rate plot, and we get the number of estimators is equals to 10 and maximum features is equals to 4. And we get the accuracy of 79.78. So if we compare this project with the previous project, in the previous project, we get the maximum accuracy using grid search cross validation. So that data set was different. For this data set, we get the best accuracy using error rate plot. So in this way, whenever we have to implement random forest classifier, so it's better to perform all the conditions to test the classifier in all the conditions and select the best condition. So I hope you understood this project too. Thanks for listening, and I will see you in the next lecture.